Hello and welcome to the VEST webinar series. I'm Frank Newsom, your moderator for today's webinar session. And today we'll be featuring an optimized manifold design workflow using a combination of VEST cloud and desktop products. This webinar will last approximately 30 minutes. You'll be able to submit questions or comments at any time during the webinar by posting in the questions section located within your webinar control panel. Questions may be answered as they're posted, or we'll try to address them in the last 5 minutes or so of the webinar. Note that today's session is being recorded and the audio is muted for all attendees. If you're experiencing any technical issues, please use the chat window to alert our support staff. Now it is my pleasure to introduce our speakers for today's webinar session. Carlo Molon, who has worked in the hydraulics industry for many years and currently manages application sales and training for VEST desktop and cloud products. And Megan O'Neill. Megan manages scope of delivery of VEST 3D cloud products, including NetBlok3D, which will be showcased during today's webinar. With that, I will turn it over to Megan to begin today's webinar topic.
All right, thank you everyone for coming. Today, I'm going to be playing the part of a sales and applications engineer who is working closely with a customer. As the audience, you guys are somewhat playing the part of the customer. Usually I would expect a customer to be a little bit louder, but y'all are muted today, so we'll do our best. If you have any questions or comments, please feel free to put them in the chat. So with that, let's get started. So I'm going to pretend that I'm in the room with the customer and we work together to draft this basic circuit. Extremely basic because we're a little limited on time today, but we've got a needle valve here, we've got a directional control valve, we've got a logic element, and we've got a flow control needle valve as well. We have a pressure line, we have a drain line, and saying we just sketch this on a piece of paper, my first step is going to be to take this into a cloud application where I can assign some intelligent data to it. So I'm going to open up NetSkeme here. I'm going to go to New. I'm going to use a standard metric template. And I personally am not a big fan of the grid, so I'm going to turn the grid off. The first thing I'm going to do is I'm going to draw an envelope to start thinking about where I want to put my elements. And there's a couple different ways I can search for symbols. I'm going to search from the Fluid Power Tools library. If we have the enterprise version, we can upload our custom libraries and search from there. But for today, I'm going to pretend I'm the distributor. I only have access to a few manufacturers, so I'm not going to look through our entire catalog. My small circuit, I just have Bosch and Sun for demonstration purposes, so I'm going to check those off. And if I know the type of component I'm looking for, I can start looking for it here. I know one of them is a screw-in cartridge valve, flow control, and looking at my circuit, this is the one I'm looking for right now. I can add that, drag and drop, rotate, and I'm going to select information from the library. So this is how I can assign smart data to this symbol. I know this is a Sun valve, and in this particular manifold, I want to use a T13. Select this, say OK. When I go to edit this symbol, I can see all of that information is right here. It will be pulled into the XML that I can use as a reference when I'm working in a 3D environment, so I don't need to worry about what type of cavity to insert. So that's a little bit longer way of searching. If I know the model codes offhand, I can search those as well, which tends to be a bit quicker. So I'm going to find what I know will turn into a DO3. And this one, I want to have a single solenoid like so. Put it over here. I think I want my envelope to be just a little bit bigger. Everything in NetSkeme you can drag and adjust as needed. This one, since I've already searched via model code, when I edit, I see all that information is already right there. I'm going to add two more components. And I'll add this one. And let's add that logic element. Oh, that's the one we already had. It's the wrong model code. There we go. I'm going to rotate this to the right. And vertical. There we go. I'm going to move this down a little bit. Now I can start adding my ports. Looking back here, we see some BSP ports. Speaking to the customer, they said, actually, can I do SIE ports? That's entirely fine. I'm going to go back. I can add whatever types of ports I want. I'm just going to add SIE 10. And I can label them as I insert them. So I'm going to do P1, 2, and drain 1, and drain 2. So now that I have everything in, I can start making some connections. So I'm going to connect my pressure line first. Here we got some auto snap, but I didn't line things up perfectly. So I could either use the align command or just, like I did, select an item and use the arrow keys to move it as I want. This one I'm going to keep adding to the pressure line here. And I'm going to add that drain line. Selecting there. I'm going to add a couple control lines. I can move this guy over just a little bit too to get everything aligned. I want my pressure like so. And I'm going to lastly connect these two elements. I want to suppress this B port, so I'm going to add a terminator here. And now that we're done with that, I'm going to create a bill of materials. So, right, well, I can insert a ports list as well. I'll do that while we're here. So there's our ports list. And here's our bill of materials. Our one is blank because that's just our manifold envelope. If I wanted, I could edit this, say block, and update my parts list. So we've got block there. Now I'm going to save this, and this is an asset that I can save. I can save and I can share with my customer in real time. And I can also share with my design engineer and anyone else on my team. So web it 2824. All right, so now that that's taken care of, I can export to XML. Select this envelope, see my nets here. I'm just going to name a couple while I'm here. So I'm going to name the drain and the pressure just to make things a little bit easier for me. Right, I'm going to save as. All right, and now I am all ready to go to NetBlok. When I open up NetBlok, this is what I get. I get a blank manifold, and I'm going to go to Schematic, which is what I just made. And I'm just going to insert that file we just created. So once I have that file, I can see my list of components, my list of ports, and I can also see my list of nets. I've designed this manifold a couple times, and I like to start with this DO3 on top. We can see, We can see the network information here. This is our color for unlabeled net. So this is our suppressed port. I'm just going to stretch this to make it very small. I know when I transfer this over to my design engineer, he'll be able to suppress the port properly. But this is enough to get an idea of what's going on. I'm going to rotate this footprint 90 degrees. Now in NetBlok, we do have the capacity to start adding some CAD models just to get an idea of where they're going to fall. So I'm just going to add a generic CAD model here to get an idea of, I don't want to place anything on the manifold too close, so I don't want it to get interrupted. So I can see that's the CAD model, so I don't want to put anything in this area because it wouldn't be able to connect. So for now, I'm going to hide that component though, and I can still see its outline. And I'm going to go to my nets tab and start inserting other nets. So I know this is my drain net. I'm going to insert the drain here. And for someone like me, a design engineer, in the room with the customer, it's as easy as dragging and dropping. I can say, oh, I want to align these. There we go. And I can stretch to connect the cavities. Nothing has to be perfect, but I'm pretending I'm here with my customer. I'm seeing what they want, and they're saying, actually, I want that port a little lower. I'm going to say, okay, that's fine. And I can make them a little bit lower. If they've got any face or dimensional constraints, I can use those as well. Now I'm going to make this connection, can angle a cavity. I'm going to say angle 90, angle 20. That looks like it should work. I'm going to stretch it out. I probably want a little steeper of an angle. And if this is something that tooling can't accomplish, my design engineer will know that, and he will correct some of these angles. But we're just getting an idea of what the layout looks like so the customer can start to think about this manifold. So looking at net 2, start adding some components from this net. And I'm going to want them in a different orientation. No, I want net 4 right here. I can keep moving these around. They're very easy, just drag and drops. Look at this. I'm going to make this connection. So I can also use connect cavities. I want to connect the yellows. I like having this green net. Since it's only got these two, I'm pretty sure I'm going to need some sort of construction port. But as a design engineer, as a sales application engineer, I know my design engineer knows a little bit better about what construction ports our manufacturers like us to use. So I'm going to leave that up to them. So as I continue to move this around, we've got everything from red included. Need to add one more blue port, and we can just keep on connecting these. So when I make this connection, I can see this port's a little bit big. So I can use connect cavities to connect here. It automatically adjusts that drill diameter to make a good connection. So I'm going to actually put this guy on the opposite face here. I'm going to bring this all the way around the block, downwards a little bit. And my connections here don't have to be perfect because I know that my design engineer is going to check these connections in MDTools. I can leave a little bit of slack here and say, oh, I'm definitely going to need to angle this hole. Give it an alpha 270, beta 10. And we've got a connection there. And I'm going to just stretch out this red one. Oh, that isn't perfect, so I'll use connect cavity. Connect. There we go. And I know I don't have my green net connected, but that's okay. This is enough to start sending to a design engineer. So if I wanted to continue to add more CAD models, I could do that here. I can see I've got component 4. which looking back at my schematic is a logic element. So I can look for some generic logic elements. Oh, I misread that. Apology. That was our flow control needle valve. Look at a couple needle valves. And if the customer's in the room, we can say, oh, this is about what it'll look like and about how much space it'll take up. So I'm going to save this MDXML as. And I can send that with Carlo. I also have the ability to create a layout drawing, which here it's going to check the design. There's errors in the manifold. What errors are they? Some of my ports are a little close. I have a dead area intersection, and my net 5 is broken, but I knew my net 5 was broken, and my design engineer will have this same design check opportunity as well. So I know it's not perfect, but we can start to think about it. I can also talk to my customer and say, look, we have a little extra block space. Could I reduce the length of this down? Yes, I could. That looks pretty good. So now we've got a cube. I'm going to resave that so I can send it to Carlo. And if I were to create that layout drawing, this is about what I would see in my layout sample. And this is an asset I could share with the customer as well. This is one that I've created previously, so it has a couple additional CAD models added to it. So I'm going to stop my screen share, send those items to Carlo, and Carlo's going to show you how we finish a design, create drawings, and get it ready for quoting.
Thank you, Megan. Thank you for making me the presenter. So while I wait for assets from Megan, they should be coming from Skype. I think you can see my screen, and yes, let's wait for the asset to come. So today I will be using MDTools 900 series, and now I got my assets, and let me download them. So I got both the diagram and also the MBXML file. So I'll start with MDTools 980, but it will be the same exactly if you have a Inventor version. Today I'm going to use a SolidWorks version. So I'm going to import the asset I just got from Megan, which is the webinar 24. So that's the XML, and here it is the MBXML file. So at present, Megan has been using what we call a NetBlok. NetBlok. It's not the NetBlok Enterprise. Enterprise version is a version we are working on, which will include the ability to upload a customer MDTools library. So the geometry that come here are like a default MDTools library. It is slightly different from what I normally use, so I can keep those cavities or replace with what I have. So as you can see, I have imported my diagram. When I'm importing my block, when you import it, it will come into virtual mode, and we can start designing it. So like Megan said, there was a drill to be suppressed. So I will just go and suppress it. So I will suppress the drill. And I'm starting a bit of the block, so I can see the green lines to be connected. There will be no easy connection here. I will like to sink my cavity a bit, so I'll edit my sunk valve and make a 25 depth locating shoulder. When you do that, I will need to reconnect the cavity, so I will do a connect cavity and do double connection with port number 1. I don't like this port to be so close, so I will suggest Megan a modification. I'll change face to my cavity and put here and do the connection to port number 1. as well. Also reading at the labels, I can see drain 1 and drain 2. I see very large drill for drain. So in this case, I'm going to, of course, I'll do a change compared to the diagram, but I'll discuss with the customer if it makes sense to use a different size. So I go for a short port. SA ports, I'll take maybe a -6 size, keeping the same diameter. And similarly, I do the same here, keeping the same diameter. Eventually, I can look for some optimization. I'll need to make my connection, so I'll add a construction port to port number 2. My default, I have BSP plugs. Most likely, this customer will not need BSP plugs, so well, let me place it, and I'll be able to replace the plug later. If the customer is using short ports, either I replace the block with short port plugs. Maybe number 3 should be enough, drill depth and diameter. Or in my settings, I will be able to change my default for construction plugs. I can look at further optimization for the volume of the block. I can see here a bit of a tricky situation. So these drills are very close. So instead of doing this inclination, I'll change the inclination. So I go and stretch this drill on the opposite side. So I'll make 180 degrees. 80 degrees. We get a warning that the drill is too large. So now I will make it 6 millimeter. And since I have 6 millimeter, I will use match properties and apply the same drill to the footprint. So I will apply just the drill diameter. Since I have an inclination on this direction, it is not convenient to have also this drill with the other direction. So I will make it straight. So no inclination here. And I'll add a construction plug. So I go to my cavity library, go to my short port plugs and take a short port number 2 and place on this side, connecting here and here. Eventually, I can optimize a bit the drill depth. So by using the check band command, I will be able to optimize the drill depth. In terms of volume, there is a lot of room for improvement. I can reduce the size of my block in the height. I can see that here I can remove maybe 15 millimeter. That's probably too much, 10 millimeter. Then I can notice that there is no mounting holes, so I suspect they will need some mounting holes to be able to assemble the block to the frame. So I'll add maybe a couple of M8 on the bottom face. Maybe M8 is too large for this size, so let's go for an M6, and maybe we change the position. It will be possible to add also through bolt holes. I can see some overlapping spot face, so I will just use my move multiple and move my 2 cavities up a bit. And maybe use the align command to make a correct alignment of the drills. I have not checked a lot the precision, the design units. I can see that this connection is not good. This is checked with MDTools by using the check command with quality of connections. So the connection is probably opening enough the drill, but I really don't like because it's getting very close to the tangent of the drill. So I'll make an alignment between these drills. Hopefully it will not be bad. Well, let's move slightly to the right. If I use the move command, I can see the position, the actual position of the drills. I have not checked all the positions. Since I like to have a precise position without too many decimal places, I'll use a precision command to change the precision of my block and move to 0 for all location, depth, and inclination. So then I'm making sure that my machine drawing will be good. I'll then also stretch my drill, because since I have moved my cavity, I have lost this connection. I'll run another time the check band command in order to optimize all the drill depth. And I think now I'm good to go with my assembly and machine drawing. There is still room for removing a bit of material on the bottom face, 85, and maybe also on the length. So I think I can in the block size, I can in the length, I can put a cutting plane and remove maybe 15 millimeter on this side. So now I have reached a sort of first optimization. Maybe it's too much. Let me add some millimeter here on the length. Let me add 5. Eventually, I can go for assembly drawing and, of course, machining drawing as well, and align cavities. I will switch to feature mode. So, like I said, when we import an MBXML, it will go into virtual mode. Let me save my block, and I go to my webinar folder, library, manifold workflow. That's my manifold for Megan. I will convert into feature mode. I can look at engravings as well. I can see there is a port named 6, so most likely it is a mistake in the diagram. So we have P2 and probably this is P1. So let me edit. I communicate with Megan that this may be a mistake. So let's put it as P1, and maybe the location, the new location, we can define a new location for the engraving. And it is possible to massively change all engravings, so we can make it all the height as a 5 millimeter and make all non-cosmetic engraving. So this operation will change all the text height for engravings into 5 and also making engraved text. So I can see P2 as not a good spot, so let me move to a new location. And similarly, we go to item 5 and move it to a different location. Let me go for the assembly drawing. Well, here we could do again some design check. I can see that this connection is not well optimized. Let me do an alignment. Align cavities. And similarly, I'll do alignment with the first cavity. The reason to do the alignment here and not with the bottom cavity is because this drill will go through the first cavity and then enter in the other. So to make better operation, it's better to go center to center, and then I do the offset connection just at the end. It will be possible to do a manufacturing check, which will show if there are inclined drills, but nothing else. So all the other manufacturing check are correct. I just need to be aware that there is an inclined drill. Let me go for the assembly drawing. So I'll open a new assembly, and I'm going to place my block, and I'll put all the plugs here, and eventually I'll be able to assemble my valves. So the DO3 is a Bosch Rexroth for W6D, and click OK. Then we have a logic element. It was a sun valve. Hello D. Then there was a flow regulator. Now, of course, I could go into the diagram and look at the file. So I will have a part list, and that is an NCB, and there is another valve, the T13A, which is another sun valve, NFC. You can look for NFCC, and that's my sun valve. When I'm done, I click update, and now the components will be assembled on the correct spot. So the 3D model is ready, so I will be able to share a step file with Megan. But since I want also to get a quotation from a manufacturer, I will move to the machining drawing. So I'll quickly go to machining drawing, create the views for my block, and scale 1 by 1. While the paper is probably too large. Let me change format. Sorry. Properties. I go for an A2. Let me re-add the views of my block, so it's easier to first select the items. So create views of my block, and then I'll put all the machining callouts. I normally like to have the machining callouts for my block, and I'll put all the dimensions. I produce also a cavity list for my manufacturer in order to get a list of tools needed for manufacturing the block. So that will be my cavity list. So with my cavity list, I'll place it in the drawing. And I'm just good to go. I just need to relocate all the machining callouts in order to help readability of the drawing. With latest version of MDTools, we are grouping also identical operation in the same footprint. So in this case, it's describing 4 times the M5 bolt holes for the NG6 valve. And it is possible to group identical callouts. But I think we are good. So my drawing is ready to be shared also with the manufacturer to get a quotation. I have the MBXML file which I can return to Megan to share with the customer. So if I get back here, I'll be able to export MBXML, which can later be opened again into NetBlok so that Megan will be able to share with the customer. So I show you since I'm here. And then I think we can close this webinar. So I'll open, so sorry for being 3 minutes late. I will be able to open my MBXML file here. So Megan will be able later to get back to the customer and share or share a step file and machining drawing. So let me go to my webinar folder. And now I have my final design with all the components and engraving and so on. So I turn it over to Frank, and thank you. I don't see any question here, so I hope you enjoyed the workflow. So basically, we started from a schematic made in the cloud. We went through a cloud software for making a quick layout of a manifold, and then we finish it off with the desktop software in MDTools and get back to the cloud with the output produced. Thank you, and back to you, Frank.
All right, thanks, Carlo. So that is all the time we've got today. So if you think of any follow-up questions for us after the webinar, you can send us an alert email to support@vestusa.com with details, and we will follow up with you within 24 hours. And once again, I want to thank both Megan and Carlo for delivering today's webinar topic. We'd be grateful if you can complete a short survey at the conclusion of today's webinar. Also, tomorrow you'll receive a link containing to view a replay of today's session. Feel free to share this link with any colleagues that you have. A link to view video segments from prior webinars will also be provided in that email. As you can see, I think Carlo has it up, but we do have the webinar series posted on various social media channels. We invite you to follow these channels so you can receive the latest updates on our upcoming webinars, as well as any product releases. Our next webinar is scheduled to occur Tuesday, February 20th, where we will share insight into efficiencies that can be achieved utilizing the MDTools Library Manager. Thanks again, Megan and Carlo, and thanks to everyone for attending today's session. Have a pleasant and safe day, and we look forward to your feedback on future webinar topics, which can be reflected in the survey that will launch shortly.